Okay, so here we go with part two. I might talk a bit quicker because I've just had my coffee. So, what we're going to talk about in part two is various different methodologies. Now, methodologies form a large part of the taught material of this course, and it's really important that you know what these different methodologies are because we are going to be expecting you to use them in the future, and you were expected to learn these to do your coursework and also expected to use them in the exam tomorrow. So there are, let me count, how many have I got down here? 6 different methodologies. So this part's going to focus on going through just a summary of what the methodologies are and how you can use them. So without further ado, the first method is the waterfall method. So waterfall methods of project management and of product development are very, very common. Waterfall methods are simply where you start at the beginning and you finish at the end, and you don't really iterate around this very much. So the waterfall methodology, you start by talking to a customer, capturing their requirements. So you find out what the customer wants. Second up, you write out a requirement specification. Then you take the requirements and you build a design. The design is then taken and implemented. This implementation is then tested. It's then integrated and deployed, and then evolved as the customer's needs are updated. So it's quite a linear process. Waterfalling, so not looking backwards between requirements and design, then implementation, and so on. So there are a number of different advantages and disadvantages to this method. The advantage is it's quite a simple method to remember, and it's quite a simple methodology to actually use. So you know where you stand. So you've got different people working at the different stages. Once one team has finished, the project is handed over to the next set of people, and so on. The disadvantage is if you make a mistake earlier on, then these mistakes have to be rectified, and this has to filter through to each of the subsequent stages. So mistakes can actually be really costly to fix. So imagine you missed or you got wrong a user's requirement, but you're now at the integration stage. You've got to go back and you've got to redesign it, you've got to re-implement it, you've got to do all of your testing again. So this is a massive overhead for any kind of change. So the waterfall method is highly suitable where you've got a constrained and well-defined set of requirements initially. The most common place where the waterfall method is used is in construction. You can't put a roof on a house if you've not built the frame or you've not constructed the walls. Software isn't the same as physical construction. You can actually be implementing prototypes while the requirements are being captured to help the process of eliciting precisely what it is that the customer wants in terms of their requirements. In the standard waterfall method, there is no way in which you can actually feed back that information from the implementation stage back to the requirement stage. It's very difficult and it's very costly. So waterfall method, quite linear, quite simple to understand, but not very good if the requirements are changing. There are a number of variants on the waterfall method. Royce's method is, or Royce's model is where you use something similar to the waterfall method, but you feed back information between the different stages. So you produce a working copy of the requirement specification, and then it's given to the designers. The designers produce a design and then go back to the requirements and refine this, and this cycle continues until you're satisfied. Then exactly the same process happens between the design stage and the implementation stage, and so on. But again, if there's a problem with the requirements and you've got to the implementation stage, then all of those stages have to be done again. Something that was very popular some some 5 years ago in industry was what you call big design up front. A lot of resources in terms of money, time and people were spent getting the design absolutely perfect before passing it on to people who were going to implement it. So big design up front had the advantage of that everything was planned to the last detail. However, due to the nature of life in general, it can be very, very difficult to anticipate what any of the problems could be at the implementation stage. So this has fallen out of favour in industry of late. A similar methodology, which again is commonly used in some of the more archaic, not archaic, that's a bit rude, but more of the old establishment type companies in things like aerospace for development, is the V model, where you have 3 different stages. You have all of the designing stages down one side, all of the testing stages at the other side, and the implementation at the bottom. And at every stage there is different levels of testing. So please refer to the lecture on spirals, V's and waterfalls for more details on the V model. Why it's popular is because there's a lot of testing in it. Why it's unpopular is, again, if there's a problem with the requirements, by the time you've figured out that you can't implement it, you've got to go through all of the testing stages as well as all of the development cycles too. So this can prove costly. The spiral model is a little bit more popular. What it means is that you put multiple waterfalls together, forming multiple different versions of the same product. So for example, you build a small prototype. So you capture some requirements, produce a basic design, implement it, and then you show it back to the customer for an evaluation. The customer then refines the model, and this continues until you've got a fully functional working product, which you then integrate. The spiral model, developed in about 1986, has been shown to be quite an effective way of producing software. A thing about the spiral model is that you can include different levels of granulation for each spiral, so each waterfall within the model. Again, it's got its advantages, is that you are actually iterating, so you're developing the product as you go along, so it doesn't have some of the problems of the static waterfall model. However, again, it can be difficult to see exactly what problems are in the future, and you can't adapt very rapidly or very quickly to changes in customer requirements. Evolutionary prototyping is somewhat related, or rapid prototyping, where again you get almost a quick and cheap version of the requirements. You build products and then you build them up on existing on what you've already developed. Throwaway prototyping is where you build a prototype but it doesn't function very well, so then you chuck it away, use the best bits, and then carry on from there. So rapid prototyping can be very good, again, when there's a dynamic element to the requirements process. These things tended to work really well as well when you had massive teams of people working at each stage. So you'd have 10 requirements engineers and business analysts. You'd have a whole design team. Then you'd have a whole team of maybe 30 to 40 developers and a testing team, and then a deployment team and a software evolution team. However, now companies are trying to trim. They're sort of trimming the fat basically in these processes. And these things are less popular because you do need a lot of people to make it work. So therefore, more agile methods are becoming more popular. So agile has been developed over the last 15 years or so, and it's what I was taught in terms of software engineering. So there's a document called the Agile Manifesto, which aims to change the way in which people think about software development. So what they say is that they have different values which they feel are important to the software development process. And this is laid out in lecture 14. So they value individuals and interactions over processes and tools. So really understanding what the individual stakeholders of a system actually want. They value working software over comprehensive documentation. So milestones are not met once a certain piece of software has been documented, but once it's actually working. They value customer collaboration over contract negotiation. The customer is actively involved in the development process, not they just get some requirements from them, then the customer is kept in the dark until they actually see the end product. The customer is involved at every step of the way in refining the design and refining the implementation. This means that the customer is much more likely to get the product that they actually want. And possibly the most important thing about the Agile Manifesto is it outlines the fact that Agile teams must respond and embrace change over blindly following a plan. If the customer changes their mind, then you must adapt to it, no matter how late in the project this change comes. And being able to respond to change because your code's written well enough is a very important thing in terms of Agile development. So while it's still important to have processes, tools and plans, knowing what the individual wants, having working software, working together with your clients and being able to respond to change is seen as just as, if not more important. The actual and Agile Manifesto has 12 main points, some of which I felt repeated themselves. So what I did was I compressed this into 5 main things for you to remember, okay? So if you take nothing away from these podcasts other than knowing what the 5 main principles are, I'll be really happy. So, point 1, deliver early and often to satisfy the customer. There's nothing worse than having to wait ages for our product to be developed. Even if it's not completed, the customer would rather see it. So you make small systems that show the functionality. This way it allows the customer to see whether you're actually developing what they really want or not. You must welcome changing requirements because sometimes you just don't know what it is that you want until you actually start doing it. It relies on the fact that face-to-face communication is best. Stuff shouldn't just be passed through working documents. It's not the most efficient way of communicating. Face-to-face communication and by face-to-face we don't necessarily mean being in the same room, something like a Skype conference will do, but actually talking over stuff between the development team and between the developers and the customers and between them and the management is the most efficient and effective way of working. Project deliverables are in terms of the percentage of software actually completed. This is potentially the most realistic way of assessing how a project is actually progressing. And potentially most importantly, simplicity is essential. Don't try and overcomplicate the software that you're developing. Simple software is easier to fix. Simple software is easier to maintain. And simple software is easier to adapt if you are going to be welcoming to changing requirements, if you're going to have your customer in the loop and looking at your code, and also for having multiple people working on the same piece of code at the same time. And if you understand how to make code as simple as possible, then it means that your code is much more likely to be used in the future and therefore not so much of a waste of time or a trivial exercise, which is so much more rewarding in the long term. Delivering often, producing happy customers is really, really important because then they're going to come back and ask you in the future to develop more products for you.